Okay, yeah. Alright, so hi, hello my dear students. How are you all? I hope that everybody is in best of their health, and I, Ritika, am back bringing with me another amazing session for all my dear students at the very amazing platform Unacademy. So we are here at Unacademy to ace our term 2 examinations with Unacademy Plus. Now, what is this Unacademy Plus and how to subscribe it and how to avail the offers and how to take the amazing sessions that go on here, we will be knowing in this particular session. But before that, let's know a bit about me. So, I am Ritika, a chemistry educator on Unacademy. I have completed my engineering in electronics and communication and have been awarded grade A by Cambridge English EOSL. So I hope that you stay with me over here. We are going to do a very important session of term 2 examination of grade 9. Okay, so let us know what is our topic for today. So today we are basically going to focus on the gas laws, and the topic that we're going to cover today, it is Charles' law. Okay, so in our past few classes we learned a bit about gases. We will be having a kind of quick revision and then we will be moving on towards the Charles' law. Now students, I have a small request. You can follow the channel Unacademy Champions on Telegram. Okay, the link of this channel, it is provided in the description box. Now, why to follow this channel? Because here only you will be getting the daily update of all the YouTube sessions, of all the plus classes, and also about all the ongoing offers that will be, going here at Unacademy. So to not miss any of that information, you will have to follow this page Unacademy Champions so that you can stay updated on regular basis. And also please subscribe us on YouTube. Let us target 1,000 subscribers, and that is a milestone which will be received only by your help. So what you need to do is you need to press on like button, you need to subscribe it, you need to share this channel and also press the bell icon so that you do not miss out any amazing updates. Okay. So I hope we are ready, we are good to go, and we are going to basically have a short revision about gas laws, okay, about all the things that we have already studied, and then we will be moving on to today's chapter or today's session. Okay, so let's quickly start gases. So we started with the gases and we saw some of the properties of gases. Okay, so talking about how do we identify the gases or what are some of the properties of gases, let us see. So gases, they are made up of molecules. Okay, and these molecules, they are moving constantly in all the possible directions. Then talking about the gases, they neither have fixed shape nor fixed volume. So gases, they do not have fixed shape or fixed volume. Then the gases, they exert pressure in all directions. So if we keep the gas in a container, it will be exerting the pressure on the walls of container. So we can say that gases exert pressure in all the directions. Okay, next property that we learned was that the gases, they are highly compressible. Okay, and why this thing is possible? Because the gas molecule, they have got large interparticle space between them. Okay, next is they are highly expansible. The gas particles, they have got low density. Why this is so? Because the number of particles in any unit volume, it is very less, right? Because the molecules are far apart, and therefore the density is very less. Then they have a natural tendency of diffusion. Okay, that is the intermixing of particles. And at the last we saw that the gases, they can be liquefied. So these were some of the properties of gases that we saw, and then we learned about some of the basic the gas laws, right? So what are the gas laws? These are the laws which govern the behavior of gas under the known condition of temperature, pressure and volume. So talking about these three variables, we learned about three variables, right? Temperature, pressure and volume. So these are the three basic things, or three basic conditions which govern or which tell us about the behavior of any gas. Okay, now these are the three standard variables for describing or telling us about the nature of the gas. Now what is okay, let's talk about each of them first, and then we will be moving on to the next laws. So talking about the temperature, it is the degree of hotness of any substance or any gas. Okay, so what or how we can define temperature? It is degree of hotness. Now for temperature, we are using various scales such as Celsius, which is also known as centigrade scale. We use Kelvin scale. Then we saw pressure. So what is pressure? It is the force, okay, that the gas is exerting on the walls of container. Now talking about the SI unit of pressure, we had Pascal, and some of the other units were atmosphere, we had millimeter of mercury, centimeter of mercury, etc. And volume, it is the whole space which is occupied by the gas. Okay, talking about volume SI unit, it is meter cube, and some of the other units that we use, they are liter, we have centimeter cube, etc, etc. Okay, so this is the basic, or these are the basic variables. Next we learned about the Boyle's law, right? I'm sorry. So we have already done Boyle's law. We will just have a quick revision or a quick recap. Okay, now what did Boyle's law state? It stated that volume of a given mass of dry gas is inversely proportional. So here volume, it is inversely proportional to the pressure. Now volume, it is inversely proportional to pressure. What is the condition? At constant temperature. Now that is a very important thing to remember, that here pressure should be constant. Temperature should be constant. Okay, so what is the mathematical expression that we can give? Volume, it is directly inversely proportional to pressure at temperature constant. Okay, now if I move forward, what is the condition? Okay, so here what the condition will be? P and B, they are inversely proportional. So what I can write over here is, I'll just remove it. Okay, so I written V is inversely proportional to pressure. Now if I remove this proportionality sign, I will be getting a constant. Okay, so that is equal to K. Okay, so K is what? It's a constant. Okay, now I can write P1 V1 equals to K, and similarly if I go for volume 2 at pressure 2, it will be equal to P2 V2 equals to K, and therefore I can write P1 V1 equals to P2 V2, and this particular equation, it is equal to K, that is constant, and this is Boyle's law equation. Okay. Hi Baranya, hi. I hope I spelled your name correctly. So hello, how are you? Okay, now we will be moving on to the next thing, okay, which is the Charles law. Okay, so you are in grade 10 Unacademy Plus subscriber. Okay, very well. So I welcome you over here at the Unacademy YouTube classes. Okay, now talking about temperature volume relationship in the gases. Okay, now if I give you a very simple condition of inflated balloon. Okay, now see, if I've taken an inflated balloon and I am keeping it in bright sun, what will happen? After a while, it will burst. Okay, now why did it happen? Why our balloon, it got burst? Now what's the reason? There was air inside balloon. Okay, so air inside balloon. What's the reason? It got expanded. And why it got expanded? Because of the rise in temperature. Okay, so on the basis of this thing, what we can say that an increase in temperature at a constant pressure, it causes increase in volume. Okay, so if pressure is constant, okay, what I can say that if temperature is increasing, what will happen? The volume, it will also increase. And if our temperature, it is decreasing, volume, it will also decrease. And the condition that is needed here is the pressure should be kept constant. Okay. Now, there was an experiment done by Jacques Charles. Okay, he tried to study the relationship between temperature and volume of the gases. Okay, and this law, it was again studied by Gay-Lussac, and what was found, or what was the statement given, that if we have a fixed mass of any gas, just 1 minute. Yeah, so if we have a fixed mass of, let's say, any gas, what will happen to it? It will either expand or it will contract respectively. Now what's the degree? By 1 upon 273 of its volume, and this volume, it is taken at 0 degrees Celsius. For each degree Celsius rise, so at rise it will be expanding or fall. Okay, so it will be contracting for falling. Okay, in temperature. Now what is the condition that should be followed here? Pressure being constant. Okay, so that was the statement given, that if we take mass or a fixed mass of any gas, okay, it will be expanding, okay, or contracting by 173 of its volume at 0 degrees Celsius. Now it will be expanding for each degree Celsius rise of temperature, and it will be contracting for each degree fall in the temperature. And in whole of this process, the pressure, it should be kept constant. Okay, so that is the basic statement. Okay, how we can say or how we can give the statement of Charles' law. Pressure remaining or pressure being constant, the volume of a given mass of dry gas it increases or decreases. Now what's the degree of increment or decrement? By 1 upon 273 of volume at 0 degrees Celsius. Now it increases for 1 degree increase or 1 degree decrease in temperature respectively. Okay, so this was what was told by Charles' law. I'm sorry. Now if I go for mathematical expression for Charles' law, okay, how did he define it or how did he explain it? So we will be taking certain variables. Okay, now let V naught. So what is V naught? It is volume of fixed mass of gas at 0 degree Celsius. Now this is the thing. Okay, next we have taken V. V is its volume at temperature T degrees Celsius, and think over here it is constant pressure is there. So V naught at 0 degrees Celsius and V at T degrees Celsius. Now what did Charles say? That this volume V, it is equal to V naught plus V naught upon 273 into T. Okay, this is temperature and here pressure is constant. Now see students, if I take this V naught common, what I will get? V is equal to V naught 1 plus this T is in multiplication over here, so it will be T upon 273. I hope that is clear. Now if we move forward, what we can write? We can write V equals to V naught. Now what we have done here, we have taken LCM. Okay, so we will be getting V naught into 273 plus T upon 273. Okay, now over here V is equal to what? V naught upon 273 into T. Now here T is capital T, so don't get confused. This T, it is equal to this particular value. Okay, so 273 plus T. Okay, now what we can write? We can write for any given mass of gas this thing. Okay, so for a given mass of gas, we will be having this value as constant. So for this equation, what we can write? V equals to K into T. Now this K is equal to this particular value, which is a constant. Or we can even write V is proportional to T. Okay. Or we can even write V upon T equals to K. So these are the conclusions. Okay, so I hope that you might have understood it. Okay, now if I go for Charles' law, we can give a second definition to it, like volume of a given mass of dry gas is directly proportional to its temperature. So this temperature over here, it is measured in Kelvin. Okay, and what is the most important thing that we need to mention here is the pressure being constant. Okay, now we will be seeing how we can derive Charles' law equation from this law, but before that I have a very important information for all of you. Now students, you know that Unacademy is constantly and continuously rolling up some of the very important and amazing offers for all of its students, right? And again, you know that your term 2 examinations are going to start very, very soon. So it's high time, students, that you should be starting your preparations very seriously. Okay. Now, there is one such offer which is rolled up by Unacademy. Okay. Now, students, if you, first of all, this offer is for the ICSE board students for grade 9 to 12. And this offer is for plus subscribers. Now, this offer says that students, if you buy a plus subscription for 12 months and above, you will be getting the 3-month K-12 subscription as a gift by Unacademy. Okay, and with that we also have 10% discount that you all might be knowing that if you purchase a plus subscription, you can use a code and you can get 10% discount. So this time it is two things that you're going to get. First one is 10% discount, and the other one is the 3-month extra K-12 subscription. But students, this particular offer, it is only valid for first 500 subscribers, and also this offer is going to end on 31st January 2022. So we have a very less time left, and therefore I request all of the students to kindly take up the plus subscription as soon as possible. Because students, what happens in plus subscription is we will be learning very, very much. Okay, so talking about your plus subscriptions, you will be having the classes, you will be having various courses, you will be having regular answer writing and doubt classes. Okay, so in the plus subscription, we make sure that all your content, it gets covered, all your doubts, they get answered, and you learn a bit more. Okay, so there's a request that please share this news with all of your friends or all of the students, so that they can also avail this advantage, they can also avail this offer and take the advantage. Okay, and if you haven't subscribed or if you haven't gone for plus subscription, then please avail this offer. You are going to get two offers, that is 12-month subscription. If you're going to buy, you will be getting 3-month subscription absolutely free, and also you will be getting 10% discount when you're going to purchase the plus subscription for any duration. Okay, and this offer is going to end on 31st of January, so please hurry up, guys. Okay, now talking about Charles' law equation. What do we saw? What did we saw in our last, the law? We saw that V, that is volume, it is directly proportional to temperature. Okay, we can also write V equals to KT, or we can also write V upon T equals to K. So these were the three statements that we saw. Okay, now let's suppose there is any gas which occupies V1 centimeter cube at T1 temperature. Okay, so at temperature T1, it is taking up V1 centimeter cube and it is occupying V2 centimeter cube at T2 temperature. Okay, so we have got these two things. Now, as we know that V1 is directly proportional to T1, So what we can write? We can write that V1 is equal to K upon T1. And what is K here? It is a constant value. Now if I move further, by transferring T over here, what I can write? V1 upon T1 is equal to K. And similarly, we can write V2 is directly proportional to T2. Similarly, if I remove this sign proportionality, I can get this KT2. Here also K is nothing but a constant. So I can write over here V2 upon T2 equals to K. Now let's say this is our equation number 2 and this is our equation number 1. So here see students, V1 upon T1 it is equal to K, and over here V2 upon T2 is also equal to K. So from equation 1 and 2, what we can write? We can write V1 upon V1 upon T1 equals to V2 upon T2 equals to K. And the thing is constant pressure. Okay. So this particular equation that we came up with, it is known as Charles' law equation. Okay. So I hope this Charles' law equation, it is very much clear to you and you might have understood this equation, right? Now let's talk about what is the significance of this equation. Now, according to this equation, what do we know? Since they are directly proportional, okay, what will happen if I double up the temperature? The volume, it also would get doubled. And similarly, if I reduce it to half, the volume also would be reduced by half. Okay. Now let's talk about another important thing, that is the graphical representation of Charles' law. So this is how our graph, if we plot for Charles' law, it looks like. Okay, so there we have relationship between volume and temperature. Okay, and we are getting a straight line. Okay, now at constant temperature, if you are plotting the graph, they are known as isobar. Okay, so this is the term we use. Okay, so I hope that is very much clear to you. Now talking about how we can, explain Charles' law in terms of molecular motion. Okay. Alright, so talking about Charles' law and explaining it according to the molecular motion. Now see, if I go for kinetic theory of gases, what does it say? Okay, now kinetic theory, it is because of the movement of the particles. Okay, now we say that average kinetic energy of the particles of gas, it is directly proportional to the temperature, right? Okay, now if I increase the temperature, okay, if I increase the temperature, what is the effect? Yeah, so if we increase the temperature, what is the effect that we will be seeing? The particles that are present, they will start moving faster, right? Okay, and they will be, what they will be doing? They will be striking the walls faster. So they will be striking the wall of container frequently. Okay, now what happens? Because they are continuously striking the walls of container, if I keep up the pressure as constant, if I don't change the pressure, okay, what will happen? So if P is constant, the volume increases proportionally. Okay, so that means if we say at a constant temperature, at a constant pressure, okay, if we are not changing up the pressure, what happens? The volume of any given mass of gas, it is directly proportional to the temperature. This is the relation we got from here, right? What we have done? We have increased the temperature. Now, because of temperature increment, what happened? The particles which are enclosed in any container, they will start moving faster. If I keep on increasing the temperature, the particles, they will move faster and they will collide, or they will strike the walls of container frequently. Okay, and if I do not change the pressure, if I do not alter the pressure, what is the condition that I will see? That volume, it is increasing now. And this is what the statement of Charles' law states, that at the constant pressure, the temperature, it is directly proportional to the volume of gas. Alright, so I hope that is very much clear. Now, what is the significance of Charles' law? Okay, now there can be certain questions that can be asked you on the basis of Charles' law. Now, what does Charles' law say? That volume, it is directly proportional to temperature, right? Okay, so that means what? If I talk about a density, it decreases as temperature increases. And this thing, it is used in the case of hot air, which is filled in the balloons, which are used for metallurgical purposes. Okay, so there can be a question that why is hot air filled into the balloons used for metallurgical purposes? Okay, so this is the Charles law here, which comes into the use, that as volume is increasing or the temperature is increasing, but as temperature is increasing, the density is decreasing. So for a decrease in density, okay, we are using hot air to fill up the balloons which are used for meteorological purposes. Okay, so I hope that is very much clear to you. Now let us move on to absolute zero. Now what is absolute zero? Now students, see, we had an equation that V equals to V naught 273 plus T upon 273 in our Charles equation. Okay, now if I talk about the volume at minus 273 degrees Celsius, okay, if I have to take the volume, so what will be the volume? V will be equal to V naught 273, at the place of T I am putting up the value, plus minus 273 upon 273. So it will be equal to 0. Okay, now if I say what the statement means, volume of gas, it will be 0 at minus 273 degree Celsius. Okay, now Kelvin said that if temperature of any enclosed gas, that means the gas which is in the container, okay, it is lowered at or to minus 273 degrees Celsius, the volume will become 0. Now this thing, it is not actually possible. Why? Because gas, it's the state of matter, okay, so it has got obviously some of the volume. Okay, so that is not possible. Now if I go for temperature, just a minute. Yeah, so this temperature of minus 273 degrees Celsius, it is defined as absolute zero. Now all the gases, they liquefy or solidify before reaching this particular temperature. Okay, all right. So this is the lowest temperature that was reached, and at this particular temperature, that is 273 degrees Celsius, the molecular motion, it ceases or it stops. Okay. Now, as I told you, it is just a theoretical concept. If we talk about practically, this particular thing is not possible. We cannot reach up to the temperature as low as minus 273 degrees Celsius. So I hope that is very much clear to you. Now let us move on to the conversion of temperature. Okay, all right. Now if we need to convert from Celsius to Kelvin, what we can do, we can add 273. Okay, for example, if I go for 0 degrees Celsius, so how I can get it? 0 plus 273. So that will be equal to 273 Kelvin. If I need to go for, just a minute, yeah. If I need to go for, let's say, 27 degrees Celsius, then I will be just adding this 27 to 273. That will be equal to 300 Kelvin. Okay, now if I want to go for Kelvin, okay, just a minute. Yeah, so if I want to go from Kelvin to Celsius, now what I will be doing, I will just subtract 273. Okay, so if I go for 0 Kelvin, what is it equal to? 0 minus 273, and that is equal to minus 273 degrees Celsius. Similarly, if I go for 373 Kelvin, so just subtract 273 to get 100 degrees Celsius, and this 100 degrees Celsius is what? It is boiling point of water. Okay, so I hope these things are very much clear to you, and now we will be moving on to some of the questions for Charles' law. Okay, so let's start. First question says, at what temperature will 500 centimeter cube of a gas measured at 20 degrees Celsius occupy half of its volume if the pressure is kept constant? Now see students, first of all, let us write what are the values given to us. Okay, yeah. Now what are the values given to us? First of all, we have been given V1, which is equal to 500 centimeter cube. Okay, T1 is given 20 degrees Celsius, so it in Kelvin it will be equal to 20 plus 273, which is equal to 293 Kelvin. V2, it is half of the volume, which means V2 is half of 250, half of 500, that is 250 centimeter cube. And we have to find out the temperature. Okay, now since we have been told that the pressure is kept constant, so T2, it will be equal to 273 plus, let's say, T. Okay, so that is the temperature in Kelvin. Now if I substitute the values and if I put in the Charles' law, it says that V1 upon T1 is equal to V2 upon T2. Okay, now putting in the values and going for solution, V1 is 500, T1 is 293, V2 is 250 and T2 is 273 plus T. Okay. Alright. Now if we solve it, 500 into 273 plus T is equal to 250 into 293. Okay. Now 2 into 273 plus T equals to 293. Transferring, I can get 273 plus T is equal to 293 upon 2. Okay, and if I solve it, I will be getting T as, okay, I'll just write it here, students. I hope you are able to see it. T is equal to 146.5 Kelvin. Okay, so that is our temperature. And if we need to, convert it into Celsius, so how we will be doing? We will just subtract 273 from it. So it will be minus 126.5 degrees Celsius. So this is our volume. Okay. I'm sorry, this is our temperature. So I hope that is very much clear. Now let's go for a second question. Just a minute. Okay, so I hope the first question is very much clear to you. We had to find temperature. Okay, the volume was given to us and the pressure was kept constant. So at the pressure constant, the volume, it is directly proportional to temperature. So we derive Charles' law by that, and this is the equation that we use to derive our answer. Next, the volume of a given mass of gas at 15 degrees Celsius is 100 centimeter cube. To what temperature should it be heated under the same pressure so it occupies the volume of 125 centimeter cube? Now see, first things to notice, same pressure. Now, what is V1? It is 100 centimeter cube. Then what is given to us? V2. It's 125 centimeter cube. Now students, it is very important to note the temperature and to convert them accordingly. So T1, it is given to us as 15 degrees Celsius. So converting them, 273 plus 15, which is equal to 288 Kelvin. Okay, and T2 we have to find out. So we will just add 273 plus T Kelvin so that we can get it in Kelvin. Okay, now if I go with Charles' law equation, it is V1 T1 equals to V2 upon T2. Okay, now what we have to find out? We have to find out the temperature. Okay, so we will just substitute the values. First of all, what is our V1? 100. What is temperature 1? 288. Volume, that is V2, it is equal to 125, and T2, it is 273 plus T. Okay, now if I go for the solution, I will be getting, let's take it as capital T2. So T2 is equal to 125 into 288 upon 100. Okay, so if I solve it, I will be getting the answer as 360 Kelvin. Okay, now what do we need to do is we need to convert this temperature to Celsius. Now we are having 360 Kelvin. How to convert it? We'll just subtract 273 from it. So subtracting 273 from it, we get 87 degrees Celsius, and this is our T2. Okay, I hope that is very much clear. Now let's have another question. So another question says that calculate the volume in centimeter cube of air expelled from a vessel containing 0.4 liter of it at 250 Kelvin when it is heated to 27 degrees Celsius at the same temperature. Now see students, what is given to us again. So temperature 1, it is 250 Kelvin. Pressure is same, so applying Charles law. Okay. Next, volume 1, it is given to us as 0.4 liter. Now 1 liter, it is equal to what? 1000 centimeter cube, and therefore 0.4 liter, it will be equal to what? 400 centimeter cube. T2, it is given to us as 27 degrees Celsius. So converting it, we have 27 plus 273 is equal to 300 Kelvin. So this is T2, this is T1, this is V1. Putting in the values, V1 upon T1 equals to V2 upon T2. So we have 400 upon 250, that is V1 upon T1 is equal to V2 upon 300. Now transferring it, 400 into 300 upon 250 is equal to volume 2. Okay, and we can get the answer by 5. Here it is 6. Here it is 80. So V2 is equal to 480 centimeter cube. Now we have to calculate the volume of air expelled. So volume of air expelled is equal to 480 minus the initial volume, that is 400, which brings out our answer to be 80 centimeter cube. Okay, so I hope that this question is clear to you. Okay, moving on to our next question, which says, what will be the volume of a gas when 3 liter of it is cooled down from 27 degrees Celsius to minus 73 degrees Celsius at a constant pressure? Now see students, what is given? V1, volume 1, 3 liter. T1, 27 degrees Celsius, adding to 73, it makes 300 Kelvin. V2, we have to find out. T2 is minus 73 degrees Celsius. So if we convert it, that is, if we add 273 to this, it will be 200 Kelvin. Okay, now say students, again the constant pressure is given to us. So first of all, we need to find this thing, that if pressure is constant or not, of course. So click on go for Charles law, that is V1 upon T1 is equal to V2 upon T2. What is volume given? 3 upon temperature 1 is 300 equals to V2 we have to find out, and temperature 2 is given 200. Okay, so if we transfer it, this is what the equation will look like. Okay, and the volume 2 is clearly 2 liter. I think it was a very easy question, right? So I hope you might have understood and got it clear. Okay, so let's do a last question for the day today. A gas occupies 3 liters at 0 degrees Celsius. What volume it will occupy at minus 20 degrees Celsius, pressure being constant? Again, our main statement, pressure is constant. Now V1 was given to us as 3 liter. T1 was 0 degrees Celsius, which is equal to 273 Kelvin. V2 was given to us as X, that is, we have to find it, and T2 is equal to minus 20 degrees Celsius. So that means 273 plus minus 20, that makes it 253 Kelvin. Now putting in the values in the formula or in the Charles law equation. Hello Muhammad Uzair, how are you? So we are learning about Charles law. Okay, so putting in the values, I have 3 upon 273 is equal to V2 upon 253. Okay, so if I transfer it, I get 3 into 253 upon 273 equals to V2. Okay, and if I solve it, I will be getting V2 as 2.78 liter. So that is our answer. I hope that is very much clear to you. Now we will be having a quick revision, but before that, let's have a very important information, that is Unacademy subscription features. Why Unacademy? So students, there are some of the very special features, okay, of Unacademy that that are provided to you, and that is the reason why you should be going for a plus subscriber at Unacademy. So the very first is you can learn from the comfort of your home, and you will be having unlimited access to all your courses. You will be taught by top educators of India at one very platform, that is Unacademy. And apart from this all things, you will be having certain things which makes it very, very important and special. So you have regular doubt clearing session and answer writing session. So we regularly have doubt clearing classes and answer writing classes which teach you how to identify certain things, or how to manage your timing, how to write answers properly, etc. Then we have an exhaustive coverage of whole of your syllabus. You have the mentorship or guidance of your educators, and all the study material, it is provided to you in the PDF format so that you can refer to it whenever you need it. Then we have regular practice tests so that you can access yourself, you can know how much you are learning and what are the things you need to work upon. We also have got live test series, okay, and the batch courses, of course. So students, this is what you get at Unacademy if you subscribe for the plus subscription. And how to do it? First of all, you can select the duration as per your requirement, as per your convenience. You can go for 6 month, 9 month, 18, 24, 48, whatever. Now, with every subsequent plan, the price per month, it gets reduced, as you can see. Okay, so you can see and you can choose the plans that you want to go with, and at the referral code option you can use my code, that is RITICKACLIVE. So that is my educator code, and that will be giving you an instant discount of 10%. Okay. Now, as I told you that we regularly are having the batch classes, the batch courses. So similarly, one of the batch is going to start from 7th of February. This is ICSE Class 9th and 10th, that is ESOL's batch. Okay, so here this batch, it is going to start from 7th of February, and the delivery of this batch is in English language. So students, if you subscribe for grade 9, you will be getting the subscription of grade 10, 11 and 12 absolutely free. So kindly make sure that you subscribe, okay, and you enroll yourself into this crash course batch, because over here your whole term 2 syllabus will be covered. Okay, everything will be told to you. You will be having regular doubt classes, okay, so that your all doubts get cleared. Next is Unacademy free special class. So what is this free special class? It is the class that is, first of all, absolutely free of cost. Okay, it is available on the Unacademy Learner app. Now, why is this special? Because over here we can have real time chat or talking or interaction with your educators. We have various chat options, emojis. We can have live quizzes through polls, and we have poll leaderboards so that you can compete with your friends. Also students, you can ask questions using question tab over there, and you can clear your doubts. Now, how to watch my special class? First of all, you need to download Unacademy Learner app. If you open the app, just click on it and click on Get Started. You will enter your mobile number, OTP, and you will sign up using your email address. You will fill in all the information that is asked, and you will be selecting your goal. So in your case, your goal is class 6th to 12th. After that, you will be selecting your class, okay, and your board, that is CBSE, ICSE, etc. You will be selecting your board and class, and after that you will be directed towards the language that you wish to learn in. You can go for English, Hindi, English, whatever you want to go for. And now, in the description of this video, you have a special class link. You will just click on that link, and there will be an option as notify me, which will pop up. If you click on that, you will be notified 10 minutes before the class is going to begin. Okay, now you can use my code over there to unlock the special class for free, and my code is RITIKACLIVE. So this is the code that you can use to unlock my special class. Okay, now let's see what are the things that we learned today. Let's quickly get back. Okay, so this was what we started with. We learned, okay, first of all, we had a small revision about Boyle's law and about all the things. Next, we saw Charles' law. So Charles' law, it states that if the pressure is kept constant, the volume of any given mass of dry gas, it increases or decreases by 1/273 of volume at 0 degrees Celsius for each 1 degree Celsius rise or fall in temperature respectively. Now talking about the mathematical expression, we have taken V naught as volume of gas at 0 degrees Celsius and V is our volume at T degrees Celsius. So this is the equation that we get on solving it. Okay. Yeah. Okay. So here we get the equation, and this equation V1 upon T1 is equal to V2 upon T2 equals to K. That is equal to, or that is known as Charles' law equation. Okay, next is if I go for Charles' law as molecular motion theory. So according to kinetic theory, the average kinetic theory, it is directly proportional to temperature, which means if we increase the temperature, the particles, they start moving faster and they strike or they hit the walls of container frequently. If I keep the pressure constant, the volume increases, and this is what it is told by Charles' law. Okay, next is absolute zero we learnt about, and we learnt about conversion. So to convert from Celsius to Kelvin, we just need to add 273. Okay, and to convert from Kelvin to Celsius, we need to subtract 273. Okay, so I hope that is very much clear to everyone. We will be learning and we will be doing more of numericals. We will be learning about the gas equation in our next class. So kindly don't forget to join this class, okay, the next class, and also don't forget to join my special classes. Okay, you need to download the Unacademy Learner app. You can get it on the Google Play Store or App Store, okay, and you can try all the features for free of cost. Okay, you can use my code which is given over here. Okay, now this is the code that you can use. Okay, all right, so students, please don't forget to download Unacademy app to watch the special classes, and also don't forget to enroll in the batch courses which is going to start from 7th of February. Students, you're going to learn a lot from the Unacademy special courses, the plus courses. Okay, they will be helping you a lot in your examinations. They will help you and we will help you to take your preparations to the next level. So let's crack it with Unacademy and let's meet in our next class. So till then, keep learning, keep studying, take care of yourself, and let us meet in our next class. Thank you everyone.